Okay, lesson 1.2, we're talking more about functions. That's what we're talking about this whole unit. Anybody know what this means? It means I love math, because square root of -1 is I. Get it? So funny. Okay, anyway, so we're going to do a quick review of last section, and that is find the domain and do a few other things. So, domain is the x values that exist on the graph. Well, there's 3 ordered pairs given. Those don't represent all the x values. Those are just a few. So we're going to do this as an interval. So we're going to say the x values for domain, right? Domain is x, start at -2, and they go all the way until 4. So we're going to say the x values start at -2, and they go all the way to 4, all the way to 4. Now, there is an open circle at -2, which means that that point doesn't actually exist. It's not filled in, but there is a filled in point at 4. So we would use a parentheses at -2, and we would use a bracket at 4 to show that that point is included on the graph. Okay, next thing. Find f of 0. So f of 0, this is asking, what is the y value when x is 0? What is the y value when x is 0? Well, here's 0. Looks like the y value is -3. Okay? Next one, what is f of 2? Which means what's the y value when x is 2? That looks like -5. And then the same thing down here, but with 4. So what's the y value when x is 4? That looks like -3 again. Okay, range is like domain, but with y's. So again, I have 3 ordered pairs, but that doesn't represent all the y values that exist on this graph. So we are going to give it as an interval like we did up here for domain. Except range will be like the lowest y value all the way up to the highest y value. Well, the lowest y value is -5, and it goes all the way to the highest y value, which is a 3. The -5 is a filled in circle, so we'll have a bracket over here. The 3 is not, so the 3 will have a parentheses. There you go. Okay? Here what we're going to do is, as given the implicit equation, find explicit form, which just means solve for y, and then use a graphing utility to determine whether each relation is a function by applying the vertical line test. Okay, let's start with the solving thing. So we're going to get y alone. So what we need to do is we need to add the x squared over, and we need to also divide by 2. And so my equation looks like y equals, I have x squared over 2, which I could write it as 1/2 x squared. And 4 divided by 2 is 2. So there's my equation. Now it says use a graphing utility, which for me is going to be Desmos. So give me a second. I will pull up Desmos. And my equation was 1/2 x squared plus 2. So y equals 1/2 x squared plus 2. Okay, so it's just a parabola. Just a parabola. So we could go over to our notes and we could just draw a little parabola. That one looked like it's going through the point 0, 2 on the y-axis. Okay, let me draw a little parabola here. It's going through this point. Wow, that was terrible. Kind of like this. Maybe yours is less, oh, I can't even fix it. Maybe yours is less horrifying, but you get the point. Okay, so you're going to do the vertical line test to see if it's a function. Oh my gosh, you guys, I can't even draw a vertical line. Someone help. Okay, so vertical line test, if I run the vertical line through, it looks like it's going to pass. So this is a function. This is a function. Oh good, I get to draw another graph. Okay, so same thing, solve for y. So we're going to subtract the x. We get -y squared equals 1 minus x. I'm going to say this is a -1. So let's divide by -1. and we get y equals, y squared equals -1 plus x. And then we do need to square root to undo the squared. So I'm going to say y is equal to plus or minus, and I'm going to flip this and make it x minus 1 because I think it looks nicer that way. So warning, this is actually two equations. It's a trick because a plus or minus means that you have to write the equation twice, one time as positive and one time as negative. So it's really two things in one. It's really two equations in one. So I'm going to have to graph both equations when I do this. So y equals square root, where's my tools here? For Desmos. Oh, they're in the way. Hold on a second. Y equals, I don't know how to get square root, so I'll do it this way. X minus 1 to the 1/2 power, same thing. We can talk more about that later. And then I'm going to copy and paste, because I want the same thing again, but negative. There she be. That looks like a parabola to me, but it's been turned. It's going through 1, 0. So let me go back and try to draw a graph that's a little bit better than last time. So we need to go through this point. All right, you can do it. Oh my, still pretty bad, but at least I got through the point that time. Okay, so vertical line test, does it pass? No, it does not. This is not a function. It goes through 2 points at one time. So it has 2 outputs for each input. Okay, I'm going to pause and let you try this one, and you can email me if you would like to know whether you got that right or wrong. Increasing and decreasing. So this is going to be pretty simple, guys. For the next little portion of the notes, you're going to be telling me where the graph is increasing and where the graph is decreasing. And no, you can't just do this. It's increasing here. Yes, I know. A 3-year-old could tell me that the graph's increasing there, but I need you to give me an interval, okay? So you're going to tell me that the graph is increasing from what point to what point, okay? And you're going to tell me in terms of x. So it starts to increase when x is 5, and it stops increasing when x is 7. So we are increasing from 5 to 7. Capiche? What about decreasing? We are decreasing from x equals -1 up until x equals +1. So we are decreasing from -1 to +1. Okay? This is supposed to go with the graph, so I will go back. But constant, so the graph is constant in the middle. Yes, I know. But that is from the x value of 1 up until the x value of 5. All right, so you're just giving this in terms of x. In terms of x. Easy enough. We don't really need that because we just did that. All right, we're going to go back to Desmos and we're going to graph some stuff and we're going to tell where it's increasing, where it's decreasing, and where it is constant. So we need x cubed minus 3x squared plus 2. Okay, so x cubed minus 3x squared plus 2. Was it plus 2? Yes, it was plus 2. Here's my graph. And I notice when you graph something on Desmos, if you just click where you think a key point is, it will tell you. And then it kind of knows that you're wanting that information, and it will pop up some gray circles that you can then click or unclick if you don't want it. Well, this graph goes down forever. So I would say this graph is increasing from -infinity until we get to x equals 0. Remember, it's in terms of x values. So this graph is increasing from -infinity to 0. Then what happens? It's going down from x equals 0 to x equals 2. going down from 0 to 2. It's not constant anywhere. But there's one more thing. It actually does go back to increasing again from x equals 2 to the end. So we would say it's increasing again. We put a little u to say there's more. And it increases again from 2 to infinity. Okay, so it's not constant anywhere. Here's another one that you can try on your own. We're also going to do maxes and mins. So I'm going to go to this picture and just label the important things about these maxes and mins. There's two different kinds. There's something called a local max or a local min, which means that it's not the highest point on the graph, but it is the highest point in that area. So like this would be a local min because it's the lowest point in that region. And this is a local max because it's the highest point in that region. This would also be considered a local maximum, but it would also be considered the absolute maximum as well, because it's not just the highest point in that region, but it's also the highest point on the entire graph. Same thing down here. This would be considered the absolute minimum because it's the lowest point on the entire graph.